Next, example number 1.12. An electric field is uniform and in the positive x direction for positive x and uniform with the same magnitude but in the negative x direction for negative x. It is given that E equal to 200 I caret Newton per Coulomb for x greater than 0 and E equal to minus 200 I caret Newton per Coulomb for x less than 0. A right circular cylinder of length 20 centimeter and radius 5 centimeter has its center at the origin and its axis along the x-axis so that one phase is at x equal to plus 10 centimeter and the other is at x equal to minus 10 centimeter as shown in the figure. Now question A. What is the net outward flux through each flat face? B. What is the flux through the side of the cylinder? C. What is the net outward flux through the cylinder? D. What is the net charge inside the cylinder? Now see, this one is the cylinder whose axis is coinciding with x-axis and center of the cylinder is coinciding with origin of the Cartesian coordinate system. Now, in positive x direction, electric field that is 200 I caret Newton per Coulomb. In negative x direction, it is minus 200 I caret Newton per Coulomb. So first solve question A. Flux, net outward flux through each flat face. Now see, if we think about the left flat face, this one, then flux passing through it, that is E1 dot A1. Now area vector that is also in negative direction. Now E1 that is minus 200 I caret dot. For this particular flat surface, the area that is pi r square and it is in negative direction, so minus I caret. So 200, 3.14 r, that is 5 centimeter given to you. So that is 5 into 10 raised to minus 2 whole square. Solve this one, you will get the flux passing through left side flat face. Then flux passing through right side flat face. So E2 dot A2. Now E2 that is 200 I caret, A2 that is in positive x direction. So pi r square I caret. Then 200, 3.14, radius 5 into 10 raised to minus 2 whole square, I caret dot I caret, that is 1. Solve this one, you will get the answer. Then after B, question B. What is the flux through the side of the cylinder? Now, if you want to calculate the flux passing through the side of the cylinder, then consider here infinitesimal small surface element at any point on that particular cylindrical surface. Suppose as shown in the figure, that is delta S. Now here, this area vector for this surface element, that is perpendicular to the electric field vector. Either you take this one on right hand side or if you take it on left hand side, means on negative x side. In both the cases, delta S is perpendicular to the electric field vector. Therefore, E dot delta S, that is 0. So flux associated with cylindrical surface, that is equal to 0. Right? Then after, net outward flux through the cylinder. So we can write flux phi, that is equal to flux passing through left flat face, flux passing through right flat face, plus flux passing through cylindrical surface. So for left and right flat faces, the flux that is same one, so we can write 2, and whatever is the answer here calculated for left or right, substitute it, and then flux passing through cylindrical surface, that is 0. Now we will get the net outward flux through the cylinder. Then after, net charge inside the cylinder, so as per Gauss's theorem, we can write Q, that is epsilon 0 into phi. Net flux we calculated here. So now we have to substitute this value of flux 5, and then value of epsilon 0, we will get net charge inside the cylinder. Clear to all of you?